This time on Captain Castle's Laboratory, we're going to be working on the Department 56 Flamingo Motel, and it got a little damaged in shipping. It's not horrible, but there's a couple of broken pieces and some smaller, finer powdered pieces. So it looks like the edge of the roof took a little bit of a beating. Then the base is off. The person that sent it to me tried to fix it, but it didn't work, or they couldn't do it, which is fine. At least they tried. So I'm going to flip it over. So this is a 3-volt piece, and this is one of those pieces that is really easy to plug in the wrong power supply, because this uses the 5mm barrel, which is very common at 4.5 to 12 volts. 3 volts are normally a headphone style jack, and so it's very common to fry the stuff. So lights on the motel don't work. So if I plug it in, I've made a little adapter, but if I put that there, touch that there, you see the flamingo lights up, the sign, and we got no light here, so this probably burned out, which happens. Could have got broken shipping. I don't hear anything rattling though, which is strange. Sometimes when they break in shipping, you'll hear the filament break, but I should have another 3-volt bulb, so we'll set that one aside for now. So here's the issue. I knew this from the pictures he sent, so I'm going to zoom the camera in. Going down. And now we're going to recenter the house. That right there. See the burns? This coloring on the wire, and that's a resistor that burned. So either a light shorted out within the house. I'm going to zoom back out now. Or the wrong power supply, wrong way. Or the wrong power supply was plugged in, which is possible. It's very common on these pieces that use that jack. So this has the lights all the way around. And of course, we have the main light. Normally, if the main light shorts out, the filament gets so hot that it pops. And, well, technically a light is a short, but it really can't short out the unit. Usually what happens is if something touches it, or wrong power supply, or the accessory. The accessory is really good at it. On the Shelby Diner, Black Cat Cafe, where you have the accessory plug into the house, either via a port on the side or on the top, you can get a short, and it back feeds through that port, because you can see they're just all soldered together. There's nothing special. There's no safety feature, just a resistor. So I'm going to move this out of the way, put it over here with the light, so that way it's out of the way. I'm going to move the chipped ceramic over here too, so I don't accidentally brush it off the bench and then I can't fix the chip. So I don't know what the resistance is supposed to be. We're going to try and figure this out. First thing I want to do is get some of this glue off and separate these wires. So we can see what we're working with. as I mentioned in other videos, I don't really use these to cut. I use them more to grab because they have a sharper grippy point than like a pair of needle nose. So I can usually use it to grab and start separating some of the glue. Sometimes you can use them to cut. Like I'm going to cut this piece here because the glue wraps between the wires at the solder joint, and I don't want to break the wires at the moment. There we go. So we have 4 wires per bundle. So we got 3 whites and 1 green on each. And the green is your Christmas lights in the front. Your whites are your positive and negative. You have long dash and text. 99% of the time, I mentioned this recently in a video, the long dash is positive. But that video, it was reversed. The long dash was negative. So, and the resistor only goes to the lights on the front. So, either wrong power supply or these lights are bad. The light here probably just popped or broken shipping. So, let's see if I got a 3-volt. Now, if you have a 3-volt light and you ever read it, they actually say 3.5 on the bottom. That's 12. And that's so that it doesn't get overly bright and overly hot. It's 120 in the unit. Might be out of 3 volts. That would be weird. So I bought some new ones recently. Apparently I bought 6 volts. The Farmer 56 has a 2 different powers. It's crazy. What's this package? 12 volt. Another package. 12 volt. Another package, and another 12 volt. Now you don't need a light. You can test it with a voltmeter if you got one. I wanted to put a light in there so we could actually see it light up. I could send it back with a brand new light bulb. Looks like I am probably out of them. Oh, found one. 3 volt, or 3.5 actually is what it says. All right, let's see if it works. I'll touch that, and there we go. Works. The reason I wanted the light is I want to test the socket, make sure the socket's not bad. Sometimes your short can be in the socket, where, and this is my last 3 volt light, so I'm going to have to get some new ones. So this cap can be removed, and sometimes the wires inside touch. And when they touch, you got a short. And you got a short, you got a problem. I'm going to go ahead and just cut off the resistor, so I disconnect those lights in the front, and I want to see if we have light. There you go. And yes, I'm going to assume that the big stripe is positive, but I'm going to verify, because you know what they say about assumptions. So, there so everybody can see. And so, this bundle should be hot. And this bundle should be negative. And it is. A lot of draw on that light. I'm going to move this over to the other port. Technically it shouldn't matter. Yeah, it doesn't. There you go. So it is a bad bulb. Now I have many bulbs that look just like this. Actually, I have a couple of bulbs. This one's 120. This one's 3. That's the other problem with Department 56. They used to change their shape. Or they'd print on the side. 12. 120, 12, 120. Or sorry, 3. I think this is the one that's burned out. But throw that away. Now we need to test the lights on the front. Now there's a couple ways to test it. One is we just lower the voltage on the power supply and test it at a low voltage and see if the power supply detects a short or an overamperage, which are basically the same for this context. And that's probably the way I'm going to do it. Because you can also use your voltmeter or multimeter, sorry, it has to be a multimeter, and put it on the diode setting. That does work, but when you have multiple diodes in a string, it'll give you false readings or won't work at all. So I'm going to plug that back in. And I'm going to disconnect. Which one did I cut? The positive or the negative? I cut the positive. So I'll disconnect the positive. Hook the negative back up, so I'll use this as my negative because I left that wire soldered on. I'm going to lower this down. I'm going to lower it to like 1.5, 1.6. Yeah. You can see the lights trying to turn on. I'm going to bump it up a little bit to 2 volts because red runs at 2. There we go. Turn some lights down for you, make it easier to see. Well, I'm going to turn down the one above me as well. So now again, a few things can cause a short when camera's adjusting slowly. There we go. So you can see we have all the lights. Right now it's set for 2.3 volts and it's drawing 1/8 of an amp or 0.15 amps. A little over an eighth, but round figures, about 1/8 of an amp. Probably within its tolerance. I don't have the OEM power supply on me, so I can't tell you what it's rated for. I'm assuming the OEM power supply is going to be between 3 and 500 milliamps, which is just under 1/3 to 1/2 amp. So the resistor is to lower the 3 volt input down to a more manageable level so it doesn't blow the LEDs. Red LEDs turn on at around 2.2 volts. Some can go as low as 2, some are like as high as 2.4, but usually 2.2 is right in the middle. I have it set for 2.3, so if I bump it up a hair, it's 2.5 now. Now I don't know if the camera picked it up, but the red one's got brighter. The green and yellow did too, but the red got significantly brighter because it takes a lower voltage to turn on. It is now pulling 1/5 of an amp, or 0.2 amps, or 200 milliamps. Actually, it's 210 milliamps to be exact. It just changed. I don't think the LED string is bad because the machine would start beeping or I would see the numbers on the machine changing dramatically. As I'm blocking the light behind me, you get into darkened light on the camera. So if I sidestep, you can see that the whole bottom lights up because there's a big old light right there. It's a very dim light. It's a big one, about 6 foot tall. So it's probably a failure of a couple things, and I mentioned this on a few other videos that are similar. This light bulb is a huge resistance. As you saw, I was getting 3 volts in But when the light bulb was put in, it was only registering about 2.5, 2.3, somewhere in there. And that's because the incandescent bulb is a big resistor. It's highly resistant. So when the bulb popped, there's a chance the voltage spiked to 3. That resistor is older, and it got really hot. When there's no protection other than a small resistor, you generate a lot of heat because you just lost your big heat sink slash resistor slash draw. And now you have a lot of power that this wasn't expecting. Which is good. I'd rather it burn the LED resistor than burn the LEDs, because replacing this string is going to be difficult. Now, the easiest way to replace a string on like these Christmas houses, and the Halloween ones too, is, you know, those necklaces that they sell at the cash registers, like if you go to a Walgreens or CVS or whatever convenience store you have, that you put in like a watch battery or the 2032 lithium, and it's on a string. It's got little Christmas lights that flash in different patterns. If you press the button 16 different times, you can actually take those strings, cut them, replace that, and plug it in, because that little battery is 3 volts. This house is 3 volts. I would still put a resistor in line. I'm going to try and figure out what resistor they used. I'm assuming it's going to be right around 100 to 200 ohms, but we'll figure it out. But right now, with it still on, it has now bumped itself up to 220 milliamps, and it's bouncing back and forth. So it's right around 215, because I don't have a third digit on my machine. So it's going between 210 and 220. So it's probably around 215, because if it is 215, it rounds up to 220. If it's 214, it rounds down to 210. So it's probably around 214, 215, which is totally fine for a LED string of multicolored lights. So normally I let these things run for a while, see if they start getting warm. What's nice about having the larger machine is it will indicate a failure. My digital one's right here, my analog one's right here. The analog one, step aside again. So my analog one's right here. And the analog one is more sensitive because it's an analog sweep, but it isn't as quick to react, meaning that if this thing goes short circuit, that will turn off immediately. This one won't. So potential of fire or damage, but not really a fire, more of just smoke. So a lot of technical stuff on this one versus, oh look, you do this, and you're done, it's repaired. Woo! This is more techno because there's a few things that can cause the problem that this one has, being a burnt resistor. The thing is probably the light bulb, because I've seen it before. They need to put a bigger resistor in. And I don't mean a higher ohmage. So this is a, like I said, between probably 100 to 200 ohm. Most of them are around 100 to 200 on all of them. But it's only an 1/8 watt resistor, which means it can only dissipate an 1/8 watt of heat. And when you bump up the voltage and the resistor is trying to hold all that power back, it gets really warm. Well, if it's too warm, it starts to smoke or burn. That's why in some of these, if you've watched previous ones, and I don't remember which ones they were, a few of the houses I put in 1 watt resistors or 1/2 watt resistors, and a couple of them that were big power draws, where if the multiple bulbs failed, I put in 2 watt resistors. An 1/8 watt, 1/4 watt resistor, when they get hot, they'll burn you. When a 2 watt resistor gets hot, it'll really burn you. But that means you also have a really big problem. So I'm leaning towards right now the failure being the light bulb. The light bulb burned out. It caused a voltage spike, which caused too much power to go to the lights. That's how you burn out LEDs. They are very sensitive to voltage spikes. The resistor is there to slow that down. The person didn't know, or the power supply is free floats too high, and it smoked. And it would smoke relatively quick. You're talking probably less than a half a minute from the time the bulb pops to the time it shorts out, or burns out in this case. That's relatively quick if you have a big display and you're not in the room with it. If you're watching it, you have enough time to unplug it. The other issue, power supply. Wrong one, or free float failure. So I don't know, this year has been a very big year for power supply failures. I'm getting power supplies that come with some of these houses. They're 4 volt, 4.5 volt, 5 volt, 8 volt power supplies, and they're putting out 2 to 3 times their standard voltage. They're not designed for that. The houses aren't designed for that. The units can't handle it. There's a problem. So if you have a 3 volt power supply and it's putting out 7, 8, 9 volts, it's a bad power supply. It's failing, and the resistor is taking the brunt. Or, like I said, because it's a standard 5mm barrel, like Lemax uses, and that's 4.5 volts. You plug 4.5 volts into this thing, this is going to pop, and that resistor is going to get really hot. And again, I don't know what happened, and I can only give you what can cause this. So if you have a piece, whether it's the Flamingo Motel or something similar that has LEDs with a little 3 volt light bulb, make sure you're using the right power supply. Get a voltmeter. You don't have to buy something stupid expensive. You can get one of the ones from China. They're like $4, as long as it tells you volts, and it's not going to give you decimal points and say, hey, it's 2.935 volts. It just says 3. Okay, or it says 4, or maybe it says 4.5. A 3 volt power supply, normally from Department 56, will put out about 3.5 to just under 4 volts with no load, meaning you just take the meter and plug it right into the barrel that you plug in. Center's hot, outer casing's not, and it's usually your free flow's pretty low. If you're getting free flow to 5.5, 6 volts, or even higher, because I've seen some that are 3 times, so we're talking 9 volts, don't use it. The power supply is failing. So when the power supply fails completely, it can actually short to where it puts in almost mains voltage, which means the house goes up to almost 120, or the power supply can actually melt in your wall socket, and that's how you cause house fires. So that's why they tell you on your cell phone chargers, don't leave them plugged in all the time. They say it's a vampiric draw, but it's also if the transformer inside that takes your 120, drops it down to 5 or 9 if you have a fast charger, volts DC, fails, that little plastic casing that is sitting in isn't going to hold back the heat. So all mine, which most I would assume would be that way, is on a switch. So I can turn them off and on banks at a time. And it's not just because it's easier to control. It's to help prevent failure. And all my plugs are accessible. You'll look at my displays and say, I don't know where they would be. Every single plug I can get to within a matter of seconds. So if I have a house that's starting to burn, I would unplug it from the back. But if I have a plug that's starting to burn, they're out and accessible, so they can also dissipate the heat and I can find it faster. Like I said, this is more of a technical video than a repair. The only repair is replacing a resistor. So let's go ahead and start that. I'm going to go ahead and turn on the lights. Whew, it's bright to me. My eyes acclimated to the dark room. I'm going to turn off my power supply and unplug it from there. I think we're going to use a 1 watt for replacement. So that is an 1/8 watt resistor. You can see how itty bitty it is. It's so small. And those are 1 watt resistors. Much easier to see on the camera because they're huge. The 2 watts are bigger, the 5 watts are bigger, the 10 watts are bigger, the 100 watts get really big. And then you have some that are the size I couldn't even fit on this bench, used for like commercial industrial applications. So I like having 1/4 through 2 watt resistors on hand. If I'm working on a car, you sometimes need much higher. I have 5 and 10 and 50 watt resistors for cars. But for miniature houses, I usually like the 1 watts and the 1/2 watts. So anyhow, They tell you what's inside the resistor kits when you buy them, and then on the top of the resistor kit, you see that number? 68 ohms resistance is what that means. So here's the one that says 100, right there. So that's what I'm going to test. I'll start with that one. Now I do test them, and you can use Ohm's Law. If you don't know how to use it, you can just do Ohm's Law online, and there's a whole bunch of websites that give you the calculator to figure out the resistance you need. It's a great little thing. It works beautifully, but for some reason, every time I do it on resistors for strings of lights, it's way off. And I know I'm doing something wrong. I put in, okay, the machine tells me I'm pulling at, my power is 3 volts coming in. I'll say 3.5 because I always take into account the free float. And it's pulling, the string is pulling 2.4, or sorry, 0.24, 0.22 milliamps. Then it tells you what your resistance should be. And it'll say like 800 ohms. And the lights won't even turn on at that much. So I don't know what it is, but I know I'm missing something. Alright, so what I'm going to do is I'm going to turn it back on. We're going to leave it at 2.5. I'm going to touch the wires together. And I'm going to tip it so I can see. And the lights are really dim. So now I'm going to bump it up to 3.5 volts slowly. 3.5. So the red lights are on, and that's it. So 100 ohms is too powerful, meaning it's not letting enough power through, and the only thing lighting is the red because the red has the lowest forward voltage. So I am wrong when I said between 100 and 200. This house is going to be lower. So we'll go to the 68. So it goes 100, 68, 47. Which you can tell I've used a few 68s on some stuff, probably some of these little houses, because all these resistors that I bought here in this kit are for the miniature houses only, not for automotive applications, because the ones I use for automotive applications are usually gold. So they conduct really good and don't throw the computers off. Now I'm going to bump this back up. We're going to go up to 3.5 volts, which should be the power supply with free float. The yellow lights are now on, but the green lights aren't. Now this is just a quick and dirty way to show you, it's not the proper way, but it's a way you can use at home if you can't figure out how to use Ohm's Law or the calculators and you don't understand what it is. It's always good to start high and go low, than to start low and go high because you have a chance of burning things out. And because this is low voltage, holding it with your fingers isn't going to hurt you. It's high voltage, you're going to have a bad hair day. So now we're going to bump it back up. Still no greens. Oh no, they're on, they're just really dim. So now I'm at 47 ohms, which is way lower than I thought. Drop the voltage back down. I always turn the voltage down when I disconnect it in case I slip and touch the full power so I don't blow the string. So now we're going to do this one. I'm sure, like I said, there's probably some electronics guy out there yelling, going, "You're doing it wrong." Well, not everybody knows electronics, and not everybody has the ability to figure things out. So this is a quick and dirty way of doing it. It does work. You can use your power supply and do this versus a machine. So the yellows are relatively bright, but the greens are dim. So we're still not quite there, and we're not drawing a lot of power. Meaning that instead of drawing a quarter, that's rounding off, a quarter amp, right now it's drawing 1/1000th of an amp because the resistor is doing its job. And look, the resistor is not hot. Oh, I bet you it's 10 ohms. I had a couple of houses recently I worked on that the 10 ohm resistors were bad. I couldn't tell they were 10 ohms until I started testing them because they were smoked, kind of like this one. I didn't even think of that. I've been fixing things that I haven't been filming because, again, of copyright. I just fixed an Elmo I couldn't do because of the music that he plays. That one video where I had no sound, even though I told you the sound works, the same reason. Yeah, gotta be very careful. I'm actually dealing with some of those issues right now with, if you noticed, our intros don't have sound anymore. And that's because it was supposed to be licensed stuff and it wasn't. So things that have music, I'm not going to be recording as much for the camera anymore. It looks a lot better. So I'm sure it's a 10-ohm, since I've had a few like that. Alright, so let's solder this thing in. While I'm waiting for my soldering iron to get hot, if you were wondering why the lights or the wires are so many, because you have the input power and then you have where it divides the light. So it comes in, one set of wires goes here, one set of wires goes to the out, so it goes to that sign, and then the other set of wires lights up here. I've had that question before. It's like, well, if it only has like 2 things, why is there so many wires? That would be the reason. The reason is the wires, they're just split. So I'm going to put some new solder on this joint here. Apparently it's not hot enough yet. Here we go. Now she is. So that'll make it easier to solder that. I'm going to tin this wire here. I'm going to cut the leads. They don't have to be this long. And now I'm going to tin one side to start. I'm going to use the little alligator clip here to hold it, because heat transfers across it and this other side can get really toasty if I'm holding it with my fingers. There we go. That's tinned. Now I'm going to use it to... So the machine's off, so there's no power on this connector. And I said I'm just using it as a extra set of hands, or another set that I don't burn myself on. Now I'm going to tin this side. Let's clean that off because it's not sticky. And now we're going to glue it to the solder ball here. There we go. So. Perfect. All right, let me turn off some lights. And close the drawer so I don't kick it with my shin. And throw away that. And turn the power on. There you go. The reds appear brighter than the others, but I'm going to tell you they're pretty close. The reds are always going to be a little bit brighter. But we got lights. Now, just got to glue it all back together. Lights are coming back. Like so. I'm going to glue the exposed ends so they're insulated, kind of what the other glue did. Then I'm going to glue this bundle probably to the back because it was glued together, and there's some snotty glue over here, and I hate when they glue it to the bottom because you can't see what to peel off. It's also hard to read here, but I'm going to glue this, and then I'm probably going to glue the wires up a little. Then this will get glued back in. It's strange. You can see the curve, and the curve, they have the light so far to the right. That's way off center. But they probably did it so you can't see the light through the window. It reflects off the back of the door. I have no idea. But that's what I'm going to do now. So this is my new glue gun. I showed it in another video. It has a temperature, and it's not flickering like that on your eye. That's how the camera frame rate, refresh rate picks it up. So that's the temperature in Celsius. So it's at 63. This thing heats up really quick, and it works on DeWalt and Milwaukee batteries. So I like it. I've been testing it. I mentioned it in another video, which at this time hasn't been up, but hopefully it'll be up by the time this one goes up. That it does pretty good. It's Monvict if you want to buy one. They're on Amazon. I'll link it below. And it goes up to 200 degrees. So I think the lowest you can set it is like 15. So that way you can control how hot your glue stick gets. So if you buy a lower melting point glue or a higher melting point glue, you have your choices. So, but anyway, since we're 37 minutes into it, I'm going to pause it for 5 minutes or so while I glue all this back together. Then we'll come back and do a low light test with the sign hooked up. So I'll be back momentarily. This has got to get hot. She's not there yet. We've still got 30 degrees. So I'll be back momentarily. Okay, here we go. So it took a couple of minutes because just as I started gluing, the battery on the hot glue gun died. So I had to switch batteries real quick. But there we go. Here's your lights. You can see that they're pretty close. The reds are brighter, which is very common. Even in here, this we didn't work on, the sign. You can see the red's brighter. In person, they're not like as bright as the camera's picking it up. But the reds are generally brighter. Plus this red, actually, all these reds are pointing more in the direction of the camera lens than the other colors too. But reds are generally brighter. If you even get the battery operated strings and you actually look at them closely, you'll see the reds are usually a little bit brighter. But looking at it in person, they don't look as bright as the camera is picking it up. Even this one doesn't look as bright as it does. So camera is very deceptive because it's how the camera picks up light. Cameras can pick up infrared and UV where your human eye can't. Red is close to infrared, so it's going to pick it up as a brighter light. Just like if you ever want to test your remote and say, is my remote dead or my battery is dead, point at your cell phone camera. You'll see a flash, but your eyes won't. So the camera lens will be very deceiving on some LEDs. But in general, the lights are pretty uniform. The sign's plugged in. The house light's on. You can see the lights in the window. You can also see the bottom glowing since it's plastic. The unit on my machine at 3.5 volts, which the machine doesn't care about the draw. So it's always going to put out the same voltage, is pulling 0.46 amps. If I drop it down to 3 volts, which is the power supply, you can see it's a little dimmer, and lights are still bright enough. I know the reds are still brighter. It's now pulling 0.38 amps. So you would want a 400, that's pretty close. I'd go with a 500 milliamp power supply. So if you lose your power supply, you want a 3 volt, half amp, or 500 milliamp power supply. If you lose your power supply, or it burns out, you need to replace it, and you go on Amazon or eBay for a generic. So 3 volt, 500 milliamp rated or higher. You can always go up on the amperage, not down below the threshold. You never want to change your voltage. That would be bad. So it's not too hard to do. You just pop the bottom off. It's glued on. Usually they'll crack off of its age. I hot glued it back on. I didn't do a full ring of glue in case it ever has to be worked on again. I just did a line, a dotted line, so it's a dash, space, dash, and another one is dash, space, dash, and then this side. And there's nothing on this side because there's not much of a lip to glue onto. So that way I'll actually get a little blade in there to pop it off. So there is the Flamingo Motel. I will tell you to be very careful when heating these if you're going to heat the bottom. Any ceramic piece that's glazed, I'll turn the lights on so you see what I'm talking about. That's one. And that's two. So, see how shiny it is? See how it reflects the light? Now if I flip it over, see how it's dull and rough? Hear how rough it is? No noise? So, glazed ceramic's really weak. It will crack under heat or shatter. I will probably have a video coming up where I'll show you. So it happened on camera. So, careful with heat. Try and break it free a little bit with a screwdriver because of its age. If you are going to heat it, start at a very low temperature. Start heating the plastic and then slowly increase the temperature. So when you glue it back on, don't put a lot of glue and don't use a very hard glue. If you ever have to open it up to change the resistor again if it ever fails, or if you have to replace the ports on the back where these plug in, they are replaceable. So, but there you go. So what it says here is the original Snow Village, the Flamingo Motel, Department 56 from 2007. So that's how you open it up, or excuse me, that's how you fix it, since it was already open when I got it. And what I'd recommend is a 5 to 10 ohm resistor at about a watt. You can go a half watt, like I said. I wouldn't go any lower. And that's just to prevent if the light bulb pops. So what it needed was a new resistor and a new light. And now I'm going to flip it over onto its front and fix the broken piece off the roof, which is over here. And that way I can get this ready to be shipped back to its owner. So, oh, piece of it slid under the machine. There we go. So I'll work on getting those three pieces glued on. Those I will glue on with a super glue, not a hot glue. But there it is, the Flamingo Motel. Good to go. Hopefully it was informative. Didn't expect it to be a 45-minute long video. But again, it was mostly a technical video to help you try and understand what can cause failures on houses that only have lights and a bulb, and what causes those resistors to burn. I've replaced many of them. I think the most recent one, the video I did, was the spider house. Same problem. Resistor burned. And I upgraded the resistor to a fatter resistor. So hopefully that gives you time to fix it before it smokes. But resistors are cheap. I'll put a resistor kit down below, probably a couple of them, so you have some choices. They're like 20 bucks for 1,000. They don't come in singles, but a resistor kit, the light bulbs. Sometimes you get them from Department 56 website. I get them from eBay or Amazon because sometimes Department 56 is out, which seems to be more often than not when I try and buy them. But I'll have to buy a new set because that's my last 3.5 volt bulb. So, and make sure whenever you plug in your pieces, you check the power supply and you're plugging the right one in. And if you have a voltmeter, stick the voltmeter on your power supply and see if it's putting out the right voltage. Again, there will be free float, meaning no load. The voltage will raise on its own because there's no load. Like a car battery. When you check them, they're like 13.5 volts. But when you put a load on them, if they're not being recharged, they drop down to around 12. Once the alternator kicks in, they go back up to 13 or so. Same thing with these AC power supplies. There's a free float or a no load voltage. And it should be, hopefully, within 10%. So if it's a 3 volt, it should be about 330. Some of them are about 350, so they're at about, what is that, 15%. When you start hitting 25%, 50%, 100%, 300%, they're starting to go bad. Start looking for a new one. You can compensate for it by changing the resistor to a bigger resistor in here. This light bulb is rated for 3.5 volts continuous. They overrate the bulb, so that way the bulb doesn't fail prematurely. And if you put 3.5 volts to it, they're a little bit brighter. That's why you saw the whole house get dimmer, because I was running at the maximum power of that bulb. You start putting 4.5 volts in there, that bulb's gonna get really bright, get really hot, and the filament's gonna pop. So watch your power supplies. Again, don't know how this happened. I can only give you speculation and reasons that cause it based on history. And this year, out of all the years I've been working on my pieces and other folks as well, I've seen more bad power supplies in this last year than I've seen since I started collecting villages 25 years ago. So, and I still have power supplies from 25 years ago that still work fine. I don't know if that's a good thing or a bad thing. That's your opinion. So, anyhow, there we go. It's done. And again, thanks for watching. Stay tuned for more repairs. Hopefully just basic repairs and not as much technical stuff. I know that's the boring stuff, but it'll help you learn and fix your own and diagnose if it was a problem that you caused or a problem that the unit caused by a failing component. So hopefully it helps. Any questions or comments, leave them below. And until the next one, thanks for watching.